That was a great introduction to SIP security by Peter. I would like to carry from there and show why you need to pay more attention to wipe security, particularly in the advent of these vulnerabilities we're going to demonstrate, how a wipe vulnerability can be carried over into data world and confidential customer data can be copied from laptops and smart devices by hackers. My name is Krishna Kropati. I'm the founder and CTO. Unfortunately, Sachin could not make it, so I'm substituting him. Sipera Systems is a unified communications and voice over IP security company. We focus extremely on developing solutions and services for voice over IP and unified communications. With that, here's the outline. First, we're going to establish some baseline of wipe versus data. And to many people, it's not obvious. People think it's another application. So we're going to talk about a little bit on that. Then we're going to show you how easy to build an attack script or a tool, just like using a Cyvus tool, like what Peter mentioned. And we're going to share some of the vulnerabilities that we have discovered and published around the devices, the dual mode phones, Wi-Fi phones, and soft phones. And finally, I'm going to show you the real cool thing, the attacks. What will happen to these devices and the QA. Sorry. Here is Sipera Viper Labs. Before I get into details, we've been working on for 4 years to find new vulnerabilities that exist in voice over IP, and we've come across thousands of vulnerabilities in both protocols, products, devices, and systems. Some of them attack the PBXs, voicemail systems. Some of them attack the end users and devices. So they exist in not only SIP, they exist in all the protocols. It's all there. And we catalog those. And Viper stands for Voice over IP Exploit Research. That's our focus. Just like X-Force for ISS and Avert Labs for McAfee, we extremely focus on voice over IP security and unified communications. And these vulnerabilities we cataloged and shared with our vendors and partners as well as the public community. So, for this year alone, we have published about 26 new unique vulnerabilities in voice over IP that are some of them we're going to show in the demo here. Again, this is another pointer just to bring it. Voice over IP vulnerability research is a special subject by itself. We combine the vulnerability research expertise, 4 years of expertise that we have, and we have developed our own Lava tools like Cyvus, but we go much beyond in complete vulnerability exploit testing and offer as a service to vendors and enterprises and carriers. So we're working closely with many vendors in this space. When they come up with a new product or services, they can take this, give us, and we can validate their products as well as the actual enterprise networks, voice over IP enterprise networks. In addition, we also have voice over IP security solutions and appliances that we sell that can be used to protect against these attacks. So let me begin with what's the difference between voice over IP and data. A lot of times it's not obvious. When you look into the details, it's kind of makes sense. I'll take an example here. Wipe is completely different. in that compared with an email, right? Email is a client-server application where clients connect to server to either download an email or upload an email. So a TCP connection is established, upload, download, TCP connection closed. Look at the voice over IP. Each phone behaves like a client as well as server. Client to make calls, server to receive calls. So if you look at it, a server is usually the one which always on, always receiving, always listening for new connections like HTTP server or email server. So in this scenario, each phone is itself a server. So there are like thousands of phones in the network. That's one of the big difference. So the servers are many and they are always listening for new calls. So always on reflects to always vulnerable. That's a key difference. And more importantly, it also uses a hybrid mechanism. You have call signaling to set up the call, but once the call setup is complete, actual media or voice or video is exchanged in a separate UDP channel, which is only, two peering networks. So you have a client server on one side, you have peering on other side, and each phone acting like a server. So that's a key difference here. So we have to treat the voice over IP differently, look at it in its own merit. Obviously, voice has evolved with Graham Bell, for 100 years in a different island. Now, when you look at that voice and what we have done is, in last 10 years, we've taken that voice as a core application service on its own island and moved it to an internet-based or IP-based application, right? So that's a key transition that happened in last 10 years, but the characteristics and behavior of the beast, voice over IP, remains the same. You expect a dial tone. You expect to make calls. That doesn't change, right? If you don't get dial tone, you'll drop the call. You put the phone down. So that's a key difference when you look at it. And you cannot, like a device, a security device, cannot sit there for a couple of seconds to process a call signaling or a media, because it will have a tremendous impact on the quality of the service. So we worked 10 years to make voice over IP to the quality level today, right? And you implement a security which is doing some data, and that reverse the progress that we made. So those are the key points here. Another way to look at is VoIP is not an island anymore. It's a very important distinction. This is one of the things that drives why you need to pay more attention to voice over IP security today. Today we're not talking about replacing a desk phone with another desk phone. We have done that for past 8-9 years when the PBXs, IP PBXs started happening. Today we're talking about voice beyond desk phone. We are talking about as an application in the core, connecting to CRM, on the desktop side integrating with Outlook and other IM presence applications. When we do that, certainly it's not an island anymore. So enterprises and carriers are all adding remote workers over the internet, because broadband is proliferating. Everywhere you go broadband. Why can't I take advantage of that? It used to be that I run a line from my enterprise back to the home to make a remote worker happen. That's a very expensive proposition. So VoIP as a service can bring that down to zero cost. At the same time, it can give the quality of service because we made it work. Mobile workers with the dual mode phones. We're going to show the demo on that. And in enterprises, we're off connecting soft phones. Everybody got a soft phone now. You can download many third-party soft phones or a major vendor soft phones. And you can download these soft phones on a mobile phone as well. So the soft phones are proliferating. In fact, Microsoft XP Service Pack 2 has a built-in SIP dialer in it. is ready to be used. I mean, RTC API, for example. So those are the things that are happening today. And fast forward 1 year from now, you will see many more dialers, many more voice over IP clients that are everywhere. So that's a big concern, because it's a server. Voice over IP client is a server. So you have thousands and thousands. Every laptop is a server after that. And other things going on, like enabling SIP trunks, not only for enterprises but also carriers peering those. And what's going to happen there, right? SIP trunks will enable you to receive calls directly into the data center instead of using PRI trunks. And that's a significant value for disaster recovery as consolidation. At the same time, can you trust a SIP trunk? Can you trust the caller ID coming through the SIP trunk? How about that spoofed by somebody else? Right? Those are the issues that keeps propping up. But we're not going to talk about that today. We're focusing on more dual mode phones and soft phones. And again, I'm going to show you one attack that can proliferate into data side, and you can copy the files from remote laptop. Another significant change is happening. My cell phone is no more a closed system. It's a smart device with hardware, standard operating system, standard applications. Today's cell phones, there are 2 billion cell phones out there. Those are changing. Roughly 600 million cell phones will be smartphones by 2009. Now, what does that mean? Anybody could download any application on those. And what is the impact of that? The openness combined with open access like Wi-Fi, Bluetooth, creates opportunities for hackers to download bots, just like you're downloading worms and viruses onto these phones. And the impact is huge. It not only affect those phones, but also can affect the carriers who are offering those services. Imagine, the 2 billion cell phone users getting spammed from 1 or 2 smartphones. So those are the observations as these dual mode phones start happening today. With iPhone is one example. We've seen many vulnerabilities on those already. So the transition is rapidly going on in that direction. So this is another kicker. Now let's look at the risk versus risk analysis here, right? Today we talk about voice over IP security, but voice over IP 1.0, which is replacing desk phone with another desk phone, closing with a voice VLAN, data VLAN, voice VLAN perimeter, so that nobody can reach it. It's just similar to the TDM system. Now with dual mode phones, soft phones, that's no more true. So you look at it, closed IP phone system is a little more vulnerable. The probability of attack increase because there are IP addresses out there, but it's still asset value is low, because what are you affecting? You may doing toll fraud, right? So you can use a VoIP system to cause a toll fraud, like what happened in the New York Times reports about the toll fraud that caught Mr. Pena, who used enterprise to spoof and made millions of dollars. But that's still a cost. But what we're going to show here in a minute that shows is not only affect the voice, but it can affect the data. That's where the cost will translate into liability, right? How do you mitigate the liability if your customer information is lost? And it's getting to the point where, it's close to the removable devices kind of model, where you got to treat the VoIP security similar to the way you treat the USB devices or something similar to that. So the risk profile. Now, Peter had a wonderful session. He talked about an hour on that protocol vulnerabilities. I'm not going to go deep into this, but many vulnerabilities exist. We all know that, thousands of them we discovered, other people are discovering those. But the important fact is the implementations are vulnerable, the protocols are not complete in security, because there's a limit to where the security becomes a usability problem. So you got to have that balance. So the protocol vulnerabilities can be solved by implementation, but many of them continue to persist as this application matures, just like what we have seen with email and other data applications. Here is a simple example I want to show you. I'm going to use this again in my attack demo. I can just replace the URL in the from with a very lengthy stuff which is causing a buffer overflow. And the buffer overflow will create the shell to execute on top of it. A very simple attack. And second, I can spoof the caller ID very easily by substituting the string caller display name with somebody else. So now I can act like my CEO. So these are a couple of simple examples, but there are many more, thousands of more, which can be used to attack the call servers, attack the voicemail. Imagine voicemail, right? Most of the voicemail systems trust the caller ID as a account or PIN number to get to voicemail. So a reconnaissance attack such as this could end up opening voicemail to the hacker. Okay, so with that, I would go into more how to build these attacks. I mean, this is very simple. There are simple techniques. Use third-party solutions, public tools like Cyvus, or you can download a whole bunch of tools out there. But before that, let me show you these protocol stacks. Particularly in dual mode phones, on the left side, this used to be existing today with closed cell phone. These are all the layers that are closed, and the only telephone application that exists on top of it. Now that's changing. We are adding these layers here on top of it. We are adding SIP. We are adding APIs from SIP into applications that you can write on top of it, integrate with Outlook, integrate with other applications. So these, now you can start jumping between these two, right? So I can start here in the SIP world and migrate into cellular world and vice versa. And as I said, the impact will be huge. I can not only affect as an attacker, if I'm an attacker, I'm using a dual mode phone with SIP client, I can not only attack my SIP side of it, I can also attack on the cellular side of it. So it takes just a couple of scripts. And it can be attacked too. I mean, we will have a couple of demos where you just send a message to a dual mode phone, it crashes. So I have several of those models. I'll go into that. Then these tools, it's very easy. Just take a laptop, download Cyvus, download a whole bunch of scripts from the internet. These already exist today. You don't have to create any. They can be used to attack a whole bunch of systems in your network. Protoss is a good example. People can download and launch. So you may have an implementation that kind of blocks those or processes it but drops it, but it can create a network overload. These kind of scripts can send thousands of messages per second. And we know that I came from building soft switches and voice over IP systems, and we always talk about 10 calls per second to 100 calls per second is the kind of a capacity of these servers we're talking about. We're not talking about thousands of transactions per second. We're talking about 10 to 100. how easy it is to launch an attack that can overwhelm PBX, that the legitimate user stop getting a dial tone. So easy to create vulnerabilities, find vulnerabilities, easy to create attacks. Now actually I want to, there are several tutorialish slides we had in the original presentation. It's there on the web, you can download, but I really want to jump into the attacks or vulnerabilities that we discovered, more importantly than spending more time on the tutorials. So if anybody interested, they can download those. So these are the real vulnerabilities. It's not theory anymore. We found these vulnerabilities. We took the vulnerabilities and created exploits. And we have tools like Lava, our tools, our own tools, where we can script these like in a minute. You know, you can use Perl script, Python script, or anything like that, as well as more sophisticated call flow scripts can be created using the tool. So with that, let me go into there are many vulnerabilities that we have discovered and launched against it and submitted the advisory. Some of them are into cert right now. So we know the format string vulnerability, buffer overflow, failure to handle malform delimiters. These are all real. These are all the real devices that are unable to process those or crash or can do buffer overflow. Server impersonation. So I'm going to go quickly into the details of each of these vulnerability. First, format string. It's very easy to create this kind of thing. Many phones are vulnerable to format strings. As you can see here, what I replaced characters with just %s this kind of implementations happen because the phones are less in processing power. If you look at it, unlike servers where you could do all kinds of security checks and all those things, the phones have very less memory, less processing. So they usually have a brute force way of developing applications, and they're more vulnerable because of that. And on top of that, there are thousands of these. It's very hard to patch them on the field. So one of the phone, we're going to demonstrate this attack, which kind of causes a denial of service on the phone. Second one, this is an important buffer overflow attack. We replaced URI from URI with some large junk followed by a shell code. The shell code is very simple, just goes, executes on the native system while you have other security products such as Windows Firewall, McAfee, Total Protection is running on top of it, because it's running in the context of the phone. When you bring up an application, even with Cisco CSA, you'll ask whether to allow or not. That's a good practice, but when you bring up soft phone, I can show you that, you have to say, yes, allow it. And after you say allow it, all bets are off, right? These vulnerabilities can be used to cause buffer overflows, thereby getting control of the laptop and attack and then copy the files. Sorry. This is another example. SIP in particular, and there are other protocols as well, are very loose in grammar. It's created for a purpose, to be very open, extensible, so that I don't have to do thousands of interoperabilities. I can fix it easily and add it easily. So the value of SIP is making interoperability easy. That's a major focus of SIP. So in order to do that, the grammar is very flexible, friendly, modifiable. So the same thing can be used by the hacker. Now here we can see a bunch of delimiters that we added and end up crashing a couple of soft phones. This is a syntax error. I mean, phones, because it's so loose, so many variations are possible, you naturally have the ability to craft a message that can take advantage of the looseness in the protocol implementations. So here is an example. I just there's a syntax error here, but it end up crashing a phone. This is another thing that Peter was talking about, impersonation. There are two things that you can spoof in voice over IP systems. You can spoof IP address, you can spoof caller ID. I mean, many of the devices are behind NAT today, right? All you see is a public IP address, public IP port. And what is behind it, you don't know. It could be a legitimate endpoint, it could be a spoofed endpoint, right? So I could pretend to be something else. I could pretend to be server. Now, because the phones are like servers, they're ready to receive messages. So when they're ready, port 5060 is a good example. Every phone opens port 5060. Every phone opens port 5061. These are the ports that are used to connect to the phone. In the event, you need to complete a call. So it's a legitimate request. The same legitimacy can be used by the hacker to cause a denial of service. So in combination with some of the other attacks that we showed, impersonation plus buffer overflow, you have a deadly weapon. Sorry. This is another example. I told you about the resources on the phone, right? I mean, the phone has only certain resources can process, let alone call servers. Call servers can also crash if you overload them, but phones can crash much sooner. If I make one call a minute to your phone, is it dead or alive, right? That's an example. So we send some of these messages very at low volume, and it's a noise in the network. It looks like very legitimate. I mean, if I'm making a call and breaking a call a couple of times, it behaves like that. So a network device or a security device cannot even detect such kind of. Even if you tune it to detect, then it end up in large number of false positives. So it's a different. That's why. So such attacks can cause denial of service on phones. Now imagine, a PC can generate, a laptop can generate thousands of such requests. If I'm doing a reconnaissance or if I'm doing a call walking like that with thousands of phones in the enterprise or in the carrier network, I'm causing a regional denial of service of the network, and nobody knows why it's happening. So this has a huge impact in terms of our ability to migrate from traditional telephony system or VoIP 1.0 to VoIP 2.0, where we are going to open up and dissolve the parameters that exist in the VoIP or voice over IP or traditional TDM systems. Now, it may be a national FISMA or a compliancy-driven activity to really detect these attacks and prevent those. We did this on many phones. Most of the phones really either crash or become useless. You can't even type anything on that. Another important thing with SIP and other voice over IP protocol is they support MIME attachment, just like email, right? So you can attach anything you want. SDP is one of the attachment that is used for negotiating media. So what media codecs to use, what media ports to use. And those things are susceptible because it's an attachment, and many devices crash when we try to play with SDP. And more importantly, I'm just showing the SDP here. The attachments could be SS7 payload. Imagine that, right? I can attach an SS7 payload into my SIP message and send it across, and that could potentially crash the SS7 network, which is the backbone of the entire telephony network in the core. So there are many things. I mean, I can send a picture. It allows me to send a picture, for God's sake, right? And how many of us really receiving pictures of email spam today, right? And it allows me to send a MIME attachment of a text message. That's how the IM is implemented in SIP. The IM is implemented as a MIME attachment. Okay, that's a text, and that could be text or a picture or a video or some kind of attachment. That could be a worm too. So essentially what we're looking at it here is how extensible it could be, how valuable it would be, and how vulnerable it will be. It's a matter of time. With that, I would segue into actual demonstrations. I think this is a fun part, really. I really like to go into the demonstrations, taking some of these exploits, vulnerabilities that we discovered. We're going to use several phones here. All these phones are vulnerable, and many other phones are vulnerable. So I took a very small sample of devices that we have tested, brought it here. So what we have here is 3 laptops. One is acting like an attacker with our Lava tools, and we use that every day in the lab. One is acting like a PBX. We use Astrix, which is popular SIP PBX, and another device which is a soft phone. So we have installed bunch of soft phones for all major vendors. We have America AIM soft phone, Cisco soft phone, Avaya soft phone, Nordal soft phone, you name it. All of them we install. And we also have one hard phone here. I guess you don't see this, but this is a SNOME phone. We have several vulnerabilities on SNOME phones as well. We're not going to demonstrate anything on this. And we have BlackBerry dual mode phone here. And singular dual mode phone that is capable of Wi-Fi. We just installed a soft phone on top of it. It allows, it's a WinCE operating system, so you can install any application that runs on WinCE. So one of them we found bunch of soft phones on for this. And then for a sake of completeness, we have put a D-Link Wi-Fi phone. So D-Link also has a next version of this, which is a Linux based dual mode phone. So we're going to use these to start demonstrating. Hemant is going to help me to run some of these attacks. First, let's make sure that we can make calls. Right, that's the first test we'll do. So we're going to use the SNOME phone to make the call. Okay. Okay, so this is the BlackBerry phone. Yeah. So this is a dual mode phone. Sorry, this is the AM. So I'm going to start a few other applications as well. Nortel soft phone. Can you make the call to soft phone? You still have active call. Okay. There is the soft phone. And we also have Cisco phone here. We'll show just one second. How do you hang up? Okay, so it's hung up. Sorry, some of these demos, when you bring it in foreign environment, they don't. This is Cisco phone, a wire phone. We also have some more phones, but I think that should help set it up. So first, let's do. I think I'll go back to my attack demonstration slide. I want to show just quickly 1 second. So what I'm going to show is bring it back the unified communications or WIPE 2.0 where we are heading to. We are already there. So as you can see, we've deployed all these phones everywhere, soft phones, dual mode phones, remote, so you don't know where they are. And I create a hacker. This is the hack. Can you show the hacking mission online? Okay. So this is the Lava tool that we built. Can you log in? Yeah. Can you go to scripts? Yeah. So we have many attacks here. You can attack based on call scenario. You can attack based on scripts. Fuzzing, you can do that. And that applies to all kinds of protocols. SIP, Skinny, 323, MGCP, any protocol you can think of. In the cool thing about it is scripts, like a Metasploit, it supports the ability to dynamically add new scripts. So if somebody detects writes a exploit, that can be easily added to the system and then used it as a run across multiple devices to show what kind of and use it for pen testing and exploit testing. So we're going to use Lava for this, and we have several scripts. I'm going to use only a few here. As you can name, the name suggests dual mode phone exploit 1, dual mode phone exploit 2, Wi-Fi phone, and then the kicker is data theft script. Okay. So with that, just come back, change it. Okay. So I'm going to show those dual mode phone attacks. After that, the real deal is the soft phone attack. Okay. So what do we do? 2, right? Okay. So here is what we're doing. First step. Let's invoke the dual mode phone exploit 1. Hemant. Okay, so we made call to this phone. So I'm going to show you probably. Can you see that? Okay. Okay. I'll show you what's going to happen. Okay. Yeah. I think the webcam I need to on, right? Can you see? I don't know. It's kind of. I think too much lighting. Okay. Sorry guys, it was pretty good in the room. Yeah, it's too bright, so I think that's the thing. Okay, anyway, so let's see what happens. I mean, I can at least show you guys hanging. Go back just 1 second. Let just show this. At least few people can see. Okay, so yeah, Hemant is going to do a server impersonation and launch one of the attacks that we've described on this. Okay, so what I get is uncaught exception, Java language illegal argument exception. That's what I got. So I'm going to say okay. So it looks good. So nothing happened to the phone. Use that phone. Now he's going to call Hemant, try to call. You want to use this one? Yep. What do you get? It says invalid. I don't know what does it invalid means, right? Okay, now I try to make a call from here. It was working before. But, how do you do it? Okay. So he's going to call this D-Link phone again. It says cannot connect, call in progress. So it's stuck in a state. Can you see this? I'll try again. See if I can show you anything. Hard. I think maybe I'll show like this. Okay, it's getting better. Yep. Cannot connect, call in progress. Okay, I think this phone has to be rebooted now because I can make call, I can receive. So a normal user using this phone would think, why am I not receiving calls? Everything looks fine. Why can't I make? So the first thing he'll do is call the service provider. What the hell going on? So that's one attack. Sorry, one single packet. Yes. Okay. So now let's switch that. That's toast. That phone is toast. Next, I'm going to take the singular phone which has WinCE operating system, and I downloaded a soft phone on this, which called Edge soft phone. Now let's try see if it works again. Can you see? Okay, you switch, right? So this is the soft phone. Sorry, kind of orientation. Yeah, that's running. I think I flipped it. Right. So he's going to run an attack on this. That's dual mode phone attack 2. Okay, vanished. Soft phone crashed, and you get back to normal cellular phone. Right. So now I got to go back and restart that soft phone again. Just one message, one simple message. Okay, I guess you can change it. Yeah. So now he's going to show another attack on this D-Link phone, which has a Linux operating system, right, and native soft client. Okay, just need to. Okay, message waiting. I don't know what the message is waiting for. Okay, it's a Wi-Fi phone. Did you cuss? So I received a call from an attacker. I answered it. Okay. Now I don't know what to do now. It's gone. So now I try to call this, which number? 6000. Okay, invalid. All it knows is to say invalid. So I can't use this phone again. So the phone is toast again. I got to reboot this phone to make it work. So each one of these is just a simple one message that I sent that caused a DOS on it. Now, if I send thousands of these messages to thousands of the phones, it doesn't take a huge horsepower machine. It just takes a low-end laptop to cause these attacks. Okay, I think that's we're going to show about the Wi-Fi dual mode attacks. I think we can close this one. Now the real kicker, the soft phone. So the soft phone is working. We made the call, and what we're going to show is, before we start the demo, I want to show you that I can not access. So this is the PC which has all the folders, everything are hidden. I mean, I don't have any files that can be accessible. So they're all proprietary. So what I'm going to show you is when the attack goes from here, a shell script gets executed, shell code gets executed, and then that gives complete control to this attacker sitting here. Okay, I can execute commands on this. I can do various things. Let's see that. Okay, so first thing is I want to show you before we start. Okay, so this is a remote file viewer program on Linux called Conqueror that we're going to use. The machine, the soft phone that's running is a trainer. We try to see what training. So no files found. So we're not able to see. The drive cannot be visible anywhere. Okay. So now close that. Okay. You start the. On the other hand, we launched this one, right? It's a simple tool called Netcat. Everybody familiar with it? Can you see? Yeah. So this is a tool that you can just say listen. So what's happening is the attack, just one message, causes buffer overflow and then sends back the message to the Netcat. It can be port. Right now we made it port 80 because everybody knows that's open port. It can be port 5060 or port 1000, whatever port that you open for going out, I can use it. And in addition, I want to show you that, we have Windows firewall, virus scanning, McAfee is active, and there is a Windows firewall. Too many icons here. Okay, so let me go to the desktop. Yeah. So my Windows firewall is on. Automatic updates are on. So everything is, as for my policy goes, everything is good. Okay. Now I switch back to the attack he's going to launch. Okay. So data theft exploit. Now go back to the no, that's fine. Go back to the NC. The NC you're running. Yeah. So now, yes. So I got the command prompt on this PC. Yeah. So now he's going to do. He can see all the files. He can browse all the files that exist on my PC here. So let me show you, right? So some files like the BlackBerry files and all those things. We can create any file now. Let's say, okay, keep there. Let me create a file XYZ or something. Just 1 second. Or C:, I go to there. I'll create a small folder, new folder XYZ, just to show that. Okay, I created that. Can you do dir? Okay. XYZ share. So whatever I do, he can see. All right. And he can go one step further. Once he has command prompt, he can share the entire directory back to him. So whole C directory is being shared now. Okay. Nobody knows what's going on my PC. Everything is calm. You know, nothing is visible. Right? He's doing all he can. I'm just stupid. Okay. Now he shared the whole directory. Let's see, can we create a file with customer data? Anybody is volunteering to give a credit card number or something like that? We could create one of those, Excel sheets are already existing. Since he can browse anything, he can see anything. So credit cards. Okay. Sorry, I supposed to create. Okay. So then I'm going to, since nobody is volunteering, I probably put my own credit card. Okay. Okay. So 4351. Don't write it, 56790124. Okay. So I created this, or I can create my password. Okay. My password, my user ID. KKK. My password. Stupid. Right? Just a password like, I want to remember my password. Okay, so I just saved it here. Okay, now can you go to that conqueror? Okay. Okay, go back. Hacked. You can see all the files, all the directories that are in my computer. Can you go to the one which we created, XYZ or hacked? Which one you created? XYZ, right? Yeah. I think it was, yeah, SQL. Yeah, so let's see if we can create another. Yeah. So apparently there's some, it can copy existing files. So let me create. Okay, so let's create it here. Okay, now see that? You can go back. Yeah, credit cards.xls. Save as. He's saving my credit cards on his desktop. you copy an existing file. Maybe the existing file it will. Why serve some? Yeah. Huh? Yeah, connect again. I think you might have do net share. Yeah, do it again. I mean, couple of iterations, the guy can figure it out. It's not a rocket science for that. Okay. Go to XYZ again. Yeah, save as. Okay. So essentially, what we have seen in the lab, right? We were able to completely copy any number of files that he chose to. I think there was some sequence error that he did, part of the demo glitch. If you do the sequence right, I mean, if you try 3-4 times, you can get through any file you want, and because that's the story. So what that really brings is security. Wipe security is no more limited to wipe. Yeah, you need to protect the core wipe infrastructure, but more importantly, the security is now bleeding into data side, and the hackers can get access to your data on your laptops, on your smart devices. That's a key thing, and this is the time you guys have to realize that the wipe security is no more an island. You got to think beyond just an island. So I guess that's my presentation and demo. If any questions, please feel free to ask. By the IP. Yes. You don't have to. We have two ways to do it. You can send directly to the phone, deliver it to the phone, or deliver through the call server. So when you call your friend's number, right, the call server or the PBX is doing translation and converting that number to IP address. So you don't have to really know it, right? And usually once you know it, you know it. So what happens is, because of the peer-to-peer nature of voice over IP, once one call you make it, you know what is your friend's IP address, right? So after that, it is like, voila. So I can make 1,000 calls and learn 1,000 IP addresses, and then directly send, bypass the call server. That's the nature of voice over IP, which is different. Yeah. Yes. Yeah, SS7 payload is basically what's happening is the carriers, when they're interconnecting, they're also going over IP. But there are points where, because of the building reasons and because of the interworking reasons, the originating carrier in the classified switch would send a SIP message by attaching an IAM, right? IAM is a message that you would send to make a call, that has charging information, very blah information, LATA and all those stuff, which they care for settling, right? That information goes and then gets translated into a SS7, true SS7 message, like ISUP message, and then delivered to the STPs and security gateways, right? And if you could craft an SSN binary message such that it can cause a buffer overflow on an STP or a security gateway, you could do that. I mean, so imagine, yes, I guess if people are as old as me, but like there was in the 1990s, there was a huge outage of MCI network caused by an STP flip, right? When STP died and came back, it had a ripple effect. The entire nation had no long distance for some time. So things like that can happen in voice over IP by using this kind of. You done? Okay, now he got it. Sorry. I know it's something to do with as simple as sequence. Yep. Okay. Ooh. Okay. Now save. Okay. Now go to XLS. Can you do that? Yeah. Okay. So sure. You got to play with it a little bit because I think. Yeah. Okay. So go back to the. So he copied one of the file into his local drive. Now he can do. So he can browse the whole directory and look at the files and do whatever he wants. That's the key thing. Yeah. It happened. Yep. We give vendors notice ahead so that they can work on it proactively. Very positive. I mean, they couldn't believe it happened, right? And they were very positive about it. The major challenge that the voice over IP vendors are facing today is catching up. The biggest challenge for them is catching up. Telephony has evolved over 100 years, and you have thousands of features that people are trying to replicate, right? And many of the features that you use, call diversion, the ton of features assume inherently that it is closed system, right? I can't spoof. I mean, it's a legitimate guy that is going to is making the call. I'm serving him. It's like concierge, right? It's not a guard. It's a concierge service. So that is the thing that we are used to. That's how it's different from data applications, because data application we started with a client server model and suspicious model, whereas data is not like that. Voice is not like that. Now you can start implementing some of these security software development practices, but there is still a chance that when you try to implement services on top of it, you would have same challenges, whether I trust this guy or not trust this guy. How can I know whether his trust level is? So those are the challenges that you face when you try to implement a software that works on voice over IP. Yeah, Bob. But that applies to any software development. Usually, it's not specific to IP telephony or voice over IP. You got to do just that piece of it, like code analysis, static code analysis or runtime code analysis using those tools. And everybody does that. The challenge is those tools tend to be very noisy. They don't know what really the problem is, because they're not context sensitive or state sensitive. So you may be able to weed out a lot of like script kiddie vulnerabilities by doing those analysis, but more sophisticated attacks are very easy to be created. Yes. Exactly. Exactly. I think user interface, you brought a very good point. The user interface is a very important thing. If you keep challenging every time somebody calls somebody else, what is the user experience would be? We were never used to getting challenged, right? Imagine when we go to website, try to buy Ticketmaster tickets, we enter those squiggly characters that come in the image, right? Assuming translate that same thing into voice over IP. Yeah? Every time somebody calls, you go and challenge him. He will be really annoyed. He's never used to it, right? Even though it's the best security practice, it's the worst user experience, right? And you got to find a balance between user experience and best security. In that sense, you have to really look into an overall security architecture, how to address this. Yep. Right. Yes, we do, because that's a reflection attack. You can start doing that when you take control of, you bounce off. When you do stuff, you send a request and it sends a bye response. So you send a bye to the phone. When there's no context, it ends up sending another message back to call server. So you can cause a reflection attack, right? So reflection attacks are very easy in voice over IP systems because there's a complex call state and protocol sequence that's anywhere you can insert and cause other people denial of service or cause denial of service on that system. Yes, yes. So as we showed you just now, one is the voice over IP bleeding into data site. We show that, how you can take control of laptop and start doing whatever you want. The second thing is you can also cause denial of service on traditional telephone system, right? If you look at the 2 billion cell phone users, right, they're all vulnerable to Skype attacks today, right? I can write a script on Skype just to make the calls, right, for all the free calls. And what happens to all of those guys? Their phones, I can send IMs to them. So there is nothing stopping me to not only just limit to VoIP, but I can extend beyond. Sure. Yes, we did. There are vulnerabilities exist in H323 protocol as well at the application level. But what happened was, if you see the legacy of H323, it was always closed system. It's not an application. It's a very device replacement centric, where TDM is replaced by H323. There are hardly any few phones which are H323 capable. On top of it, the syntax and all those things are different. So today, if I am a hacker, H323 is not my golden part. SIP is my golden part. Skinny could be my golden part. RTP is my golden part, right? Because it's again just like security officers evaluate risk, the hacker evaluates what is the easiest way to get the maximum out of it. It requires quite a bit of algorithmic capabilities to detect these attacks, because they're happening at a call state level, which you need to really go deep dive. That's one of the things we bring to the table as a company. We have our group comes from deep expertise in building voice over IP products such as IPPVXs, soft switches. We leverage that technology understanding of how voice over IP can be attacked, and we brought in the security from major security vendors, and combined those, created best real-time algorithms to solve these problems in the network. guess we got one more question. If you time for one more question, or please drop by. I'll be here, or visit our website www.cpair.com/viper or cpair.com. You'll learn more about us. Thank you very much.